4-point perspective. If you thought the previous videos in this series were confusing, then, well, you probably feel the same as Boxman. He gave up a while back and has gone missing. Although I could do with his help, it's probably a good thing he's not around for this one because we are well and truly going to be getting into the weeds. Anyways, grab yourself a coffee and a sketchbook because it's time to delve into this. So far we have covered 1, 2 and 3 points perspective, looking at how to set up a drawing in a way which gives us control. Again, I like to use the analogy that as artists we are like the director of a movie scene. Now although some things inevitably change when approaching a drawing in 1, 2 and 3 points perspective, one thing that stays the same is the picture plane. Not necessarily the size and position of this, but its shape. Given that it's always a flat, two-dimensional plane, it's like a window between the viewer and the subject being drawn. In most examples, I have the cone of vision and in turn the viewer's centre of vision directly in the centre of the picture plane. We also make an effort to draw within the cone of vision to avoid any distortion. The further away an object is from the centre of vision, the more distorted it becomes, and this is because essentially we have a limited area of view. Keeping this picture plane where it is, if we are trying to see something over here without turning our head and all of this with it, we are now intersecting the picture plane at an oblique angle. The more aslant this angle becomes as we get further away, the more distortion there is. But what if the picture plane was curved? In fact, let's say that the picture plane is cylindrical. This would mean that our cone of vision would always intersect the picture plane at a right angle. The viewer, and therefore the station point, is in the centre of this cylinder. Any line from this extending to the picture plane will be at a 90-degree angle. And this means that a full 360-degree panoramic view can be drawn without any of the extreme distortion caused by a flat picture plane. However, there is still going to be some distortion. For example, if you've ever seen a panoramic photograph, you've likely noticed how things look curved. Here, our horizontal lines will appear curved, but vertical lines will remain vertical, parallel to the picture plane. Another thing to note is that although whilst doing this we unlock a 360-degree image area horizontally, vertically we still need to work within our cone of vision. Throughout this video I'm going to explain how to construct a 4-point perspective grid which will allow you to create a 4-point perspective drawing. In a later video, I will be creating some drawings as an example. In this one, we'll be looking at how to set all of this up and I'll explain the thinking behind it. I also need to give a quick shout out to Craig Atterby's book, The Complete Guide to Perspective Drawing. This book was one of my main sources for information. I also need to note that this is very much a measured approach where we need to get used to dealing with scaled elevations and plan views of our setup. Let's begin with a simple example, or at least as simple as possible. Imagine that the viewer, or our camera, is in the centre of a perfectly square room. You might have guessed that when drawing in 4 points perspective, there are 4 vanishing points. Each of them are 90 degrees apart, one being directly in front, one being 90 degrees to the left, one being 90 degrees to the right, and one being directly behind. This creates a cross, and in this example, it means there'd be a vanishing point in the centre of each of these walls. Now, although the picture plane is cylindrical, our drawing surface is two-dimensional, and so this means that we have to flatten the picture plane and in turn our image area. Imagine this is like a translucent cardboard tube. There's no such thing as that, but let's cut this cardboard here and unroll this tube to be in front of the viewer. So it's as if we have a very wide picture plane instead. Now of course this is easier said than done. To flatten the picture plane we need to know the size of it, which means we firstly need to decide on a size for our cone of vision. Let's just stick with a 60-degree cone of vision at the moment. In knowing this, I'm able to work out the height of our image area. This would be 360 degrees long and 60 degrees high, but degrees is not really a unit of measurement that we can work with. Instead, we need to convert this. In a previous video, I had explained how to construct a perfect box to a set scale in which we measured distance in units, which in the case of a drawing like this is arbitrary. It's really up to you to define what a unit is, whether it equates to anything such as an inch, a centimetre, or a metre. In most cases, I just refer to it as a unit related to the drawing. So to work out the linear length of this picture plane, the circumference of the picture plane must be known, and there is a simple formula to do this. Now you're thinking, Dan, what? There's maths involved. Well, yes, I'm sorry, this is advanced perspective after all. To do this, we multiply the diameter by pi, not that kind of pi. Let's measure the distance from the station point, our camera, to the picture plane, the radius. The picture plane is 1 unit away from the station point, which means the diameter of this circle is 2 units. Again, I've drawn this onto a grid which sets the size for 1 unit. Now let's multiply 2 by pi, pi being 3.14, which gives us a circumference of 6.28 units. So that is the length of our picture plane and image area. The height is worked out in a different way, but this still involves some maths, sorry. The height of our image area is essentially 60 degrees from the station point to the picture plane. On an elevation view, we can see that it's this distance we need and how a right angle triangle, or half of this cone, can be used. We know this distance from the station point to the picture plane is 1 unit, and I know that this angle is half of 60 degrees, so 30 degrees. Now, I'm an artist, not a mathematician, but to work out the side of this triangle, which we could then multiply by 2, it involves some trigonometry. To work out the length of this side of the triangle, let's refer to this as side A and this as side B. We multiply side B, so 1 by tan 30, our angle. This gives us 0.577, which we can then multiply by 2 to get this full height, 1.15. So now I can outline our image area, 6.28 units wide and 1.15 units high. Because we know that our camera is placed in a square room, this means that each wall is equally spaced apart, and so we can divide this up like so. Each dividing line here represents a corner of the room where 2 walls meet. I'll also place a vanishing point in the centre of each of these. Now, to understand how 4-point perspective works, we need to understand how this curved picture plane affects the lines we draw. Specifically horizontal lines which curve as a result. For example, a horizontal line that is drawn at 90 degrees to our line of sight would converge to both the left and right vanishing points. If this line was below our eye level, let's say it's drawn on the ground plane and then projected onto this cylindrical picture plane, it would have to curve up to connect with these vanishing points. Lines that are above the eye level would curve downwards. Now try to imagine unrolling this cylinder and flattening it out whilst these lines are drawn on it. The curves will look different, more like a sinusoidal wave, and that's what we need to plot onto our drawing here. So how do we do that? Well, first of all, we need to know the height of our eye level from the ground plane. As usual, my eye level and horizon line are across the centre of my image area, but don't mistake this image area for the picture plane. Instead, this is essentially what would usually be a circle, the cone of vision, but here it's been stretched out 360 degrees. Remember, the picture plane can be any size. Now, it can't be any wider here because this is already 360 degrees. It's as wide as we can go. But in terms of height, this could scale up or down. In this case, the picture plane is above but also drops below the image area to sit on the ground plane, and although there'll be a lot of distortion when drawing in those areas outside of here, it's still necessary for us to plot some curved lines, which will be our grid lines, onto the ground plane, etc. The image area is essentially a way for us to crop an area of the grid which we can then use to draw. So back to the question we need to answer. How far up is this eye level from the ground plane? On this elevation view, we can see the distance from the station point to the picture plane is 1 unit, and we can also see that distance from the station point to the ground plane. We are able to set this at any level. In this example, it's around 1.7 units high. If you want to make your life a bit easier, then you could make this a round number, which helps to simplify a later step when constructing the grid. I'm not sure why I didn't, but let's just go with this. Here I'll draw in a line 1.7 units below for the ground plane. The curve that we are plotting for that horizontal line curves down from these two left and right vanishing points and touches the bottom of the picture plane at the ground plane in the centre here. And so the same can be done on our drawing. Through establishing these 3 points, we get an idea of how the curve should be drawn, but to draw a more accurate shape, we require at least 2 more points. These next 2 points are placed at 45 degrees at each side of the centre of vision, and because we have a square room, it means that these points will fall along the lines which are the corners of this room, because the corners of the room are also at 45 degrees from the station point in the centre. I hope that makes sense. The best way to do this is through a plan view. Our first grid line is touching the picture plane. I need to measure this distance at 45 degrees from the station point to this grid line, which seems to be around 1.4 units. Now I'm able to plot this onto an elevation view, and from this view I can draw a line from the station point back to this. Where this line intersects the picture plane is the point that I need to know, and a simple way to transfer this across to the drawing here is to do just that. Our drawing is also at the same scale, and so I can line this up and transfer that distance across like so. Now there are 5 points available to plot this curve, which is our horizontal line on the ground plane and also our first grid line. The next step is to copy and repeat these curves across to each of the vanishing points. Remember that this is a flat projection of what would exist on a curved picture plane, and these are grid lines, or in reality, imagine they are the squares or tiles on the floor in this room. The next set of curves we draw will be connecting to a point halfway between the 4 vanishing points, and we also want to plot these on a 45-degree angle, because if you've watched the previous videos you'll know that lines at a 45-degree angle are very useful when it comes to drawing grids in perspective. We can plot this at 45 degrees in our plan view to establish a distance, to do the same on an elevation view before then transferring this across to our drawing the same way as before. It takes a bit of time to go through this process, projecting these distances across, but as I said, this results in a more accurate grid. You can see how these 45-degree lines intersect our grid lines. Now the next grid line we need to plot will be 1 unit away from the first one, 2 units away from the station point, and also at the point at which our 45-degree line intersects this central line. Remember that for these grid lines we need to measure this distance at 45 degrees for the points we need to plot. So here I do the same again. As I mentioned earlier, I do recommend working digitally to set up a grid like this. It really helps to speed things up and work with all of these different views, and also when drawing and repeating these sinusoidal curves. So now we have another set of grid lines and a series of squares which you can see here. You can also see how this would appear in a plan view. If I repeat those steps to plot another set of 45-degree lines, you can start to pinpoint some of the intersections where these lines cross each other. By adding another set of grid lines further back, another set of squares are created, and you can see how these appear smaller as they are further away from the viewer. Again, to give you a better idea, here the same is done on a plan view. Now, you might have noticed that we are already at the walls of this room due to them being only a few units away from the viewer and the picture plane, mainly because I wanted to fit them on screen for illustrative purposes. However, I think it would make for a better example if I were to add a few more grid lines and essentially push these walls back. So here I've added a few more grid lines, and again you can see how these are receding into the distance. We are also further within our image area, which is good. The ceiling for this room is a mirror image of the floor, so the same grid is also mirrored above. Now this is looking a bit mad at this stage. What we need to do is outline the edges of the walls at the last set of grid lines, and we can remove any of the lines behind this. As noted earlier, vertical lines are parallel with the picture plane and are drawn as true verticals, and so I can connect these grid lines up like so. To finish this grid, I can divide up these verticals into equal units. I know that the height of my eye level to the ground plane was 1.7 units, and so I can multiply this by 2, totaling to 3.4. Let's just say that I can divide this up into 3 units. This needs to be done for each of these walls. You can also remove the 45-degree lines at this stage if you'd like to, but they can still be useful if you have them when drawing. We can also crop this grid down to fit our image area. So here is my 4-point perspective grid. Now don't feel like you have to use the entire width of this. Instead, you might be better off cropping this down and using only a section of it. As I mentioned earlier, I will be using this grid to create some drawings in the next video. I mostly wanted to focus on setting this up in this one. With that being said, I hope you enjoyed this and found it helpful. If you are enjoying this series of videos, then why not check out my Patreon page, where I have a lot of additional tutorials, along with study documents, which are essentially tutorials on paper. Anyways, thanks for watching. I'll see you in the next one.